All right, let's talk about something that trips up a lot of people in the automation world, making that jump from the classic RSLogix 500 over to the modern Studio 5000. If you've ever felt the pain of that transition, you are definitely in the right place.
So if you've ever looked at this and thought, man, this seems way more complicated than it needs to be, well, you're not alone. And that's because this is so much more than just a simple software update. It's a fundamental change in how we're meant to program.
We're not just talking about an update here. No way. This is a complete revolution in how you even think about programming a PLC. So over the next few minutes, we're going to break down that revolution, starting with the single biggest change that everything else is built on.
Okay, so let's dive right into the core of it. The single biggest change, the one concept you absolutely have to grasp to understand this new world, is how the controller's memory is structured.
Probably the best way to get your head around this is with an analogy. Think of the old way, RSLogix 500, as this super rigid spreadsheet. With fixed cells, you have to put your data in those exact spots. But the new way, Studio 5000, that's more like a flexible, modern database. You get to decide what to call your data, and you can organize it however makes sense to you.
Yeah, in the old days, we had what's called file-based addressing. Your memory was organized into these fixed drawers, like B3 was only for bits, N7 was only for integers. So your code ended up filled with these cryptic addresses like N710. And let's be honest, you pretty much needed a cheat sheet taped to your monitor just to remember what on earth N710 was actually supposed to be doing.
But now, everything changes with tag-based addressing. It's a total game changer. Forget B3 and N7. You just create your own names for things. Descriptive names or tags. The name is the address. So instead of some random number, you have motor start or flow rate, SP. You can look at that and know exactly what it is. No cheat sheet required.
So when you put these two side by side, you really see the massive difference. We're going from these physical, static addresses to symbolic, dynamic names. We're ditching the rigid, fixed files for flexible, user-defined structures. But you know what the biggest, most incredible difference is? It's the documentation.
And this is so important. With this new system, the documentation is literally baked into the PLC's memory. What does that mean? It means even if you upload a program from a machine with 0 comments, just reading the tag names tells you the story of how the logic works. That's a massive win for anyone doing maintenance or troubleshooting down the line.
All right, so now that we've got this awesome tag-based foundation, let's see what we can build on top of it. We're going to talk about two incredibly powerful tools, UDTs and AOIs. This is where your code starts to get really organized and, most importantly, reusable.
First up, we've got UDTs, which stands for User-Defined Types. Just think of a UDT as a custom template, or like a digital folder that you create yourself. Its whole job is to group all the related bits and pieces of data for one single thing, like a motor. No more hunting for scattered data points.
Let's make this real. Say we want to create a UDT for a motor. You'd create a new data type, maybe call it motor control. Then you start adding the members, everything a motor needs. You'd add a start bit, a stop bit, those are your booleans, then maybe a speed command, which would be a real number, and a fault code, which is a bigger number, a dint. Just like that, you've basically taught the program what a motor is in your system.
Okay, so you've built the template. Now what? Well, now you just use it. You create a new tag, call it pump_1, and tell the software its type is motor control. Boom. Instantly, all that data, start, stop, speed, is neatly organized under that one name. Your code becomes so much cleaner. You're writing pump_1.start, not some cryptic B3 address.
But wait, there's more. We can take this concept even further with something called an add-on instruction, or an AOI. If a UDT is the data template, an AOI is like a reusable black box of logic that works on that data. You're essentially creating your very own custom instruction block that you can use over and over again.
And this is where you really see the power. In the old days, you might use a jump to subroutine, a JSR. But an AOI is light years ahead. With a JSR, you're usually messing with global bits and pieces of data. But in AOI, it encapsulates the logic. It's protected inside its own box. It automatically handles the data through that UDT we just made. This makes it so much easier to test a single block of code, to scale it, and to update it across your entire project.
So this whole new way of thinking doesn't just stop at the software level. Nope. It goes all the way down to how we connect to the physical world, the actual hardware in the I/O tree.
And the key idea here is something called an alias tag. What it does is create this layer of separation, a buffer really, between your nice clean program tag and the messy physical wire. So your logic can use a simple name like estop_pb, and that name just points to a very specific physical address like local3i.data4.
Okay, but why does that matter? Well, think about it. In the old way, that physical address I1/0 would be hard-coded everywhere in your logic. If a technician had to move that wire for some reason, you'd have to go on a search and destroy mission, editing dozens, maybe hundreds of rungs of code. With the new way, if that wire moves, you just go to one single spot, the alias, in the tag table, and update it. That's it. Your logic doesn't change at all. It's a huge time saver.
And it gets even better because the I/O modules themselves are a lot smarter now. We're talking about way more than just a simple on or off signal. They come with full diagnostic structures, so you can see if there's a fault. They have built-in alarms for things like high limits. They even have safety features like electronic keying, which is brilliant. It stops you from accidentally plugging the wrong I/O card to a slot. And you set all this up through easy graphical menus, not by writing a ton of code.
So, let's pull all this together. When you combine these powerful tools, tags, UDTs, AOIs, and this intelligent I/O, it really forces you to adopt a whole new, modern programming mindset.
And at the very heart of all this, powering everything, is the fact that the Logix 5000 platform is a native 32-bit system. That's a big deal. It's just inherently faster, more capable, and more powerful than the old 16-bit world. And it's what makes all of these new features possible.
So, to really get the most out of Studio 5000, you have to start thinking this way. You have to internalize these key ideas. Your tags are your documentation now. You should always be grouping related data with UDTs. You need to reuse and protect your logic with AOIs. And you have to decouple your code from the physical hardware using aliases. This is the new way.
This is a fundamental shift, right? We've moved from a really rigid, linear system to one that's flexible, descriptive, and object-oriented. And that's the key to unlocking the true power of modern automation. It lets us build systems that are more reliable, easier to manage, and faster to deploy. So it really just leaves us with one final thought. Now that our code can be this modular, this powerful, what does that mean for the future of automation? What will we build next?